Welcome to queenon7.com. Please like, share and subscribe my videos. Today we're going to look at alcohols. This is particularly for the A-level students. The first part will help the GCSE students as well. Whenever you see actually OH group with any molecule which is open chain, which means the aliphatic compounds, that is known as alcohol. Alcohols obviously OH group we call as alcohol, but we also call it as hydroxyl group. So do not be surprised if you see this OH as a side chain, especially in carboxylic and aldehydes. We actually consider this as a side chain, so we do not name them on that basis. So your hydrocarbons, which are obviously you have a CH4. Now CH4, when you lose one hydrogen, will become CH3OH, means hydrogen is replaced by OH. If you want to open this molecule, you have 4 hydrogens around, and then you have this carbon with 3 hydrogens and 1 OH. Here is the general formula CnH2n plus 2, and here CnH2n plus 1 OH. So that will be the general formula of alcohols. Now alcohols will do the same thing when they do combustion. For example, if you have CH3OH and you are going to burn it means reaction with oxygen, you are going to produce carbon dioxide and water, and then you can obviously balance it. What we're going to look at today is we're going to look at how alcohol actually we can use them up. So they are used as in the drinks and feedstock and all other things, but we can also look at that how in the industry or in the other compounds manufacturing we can use alcohol as well. So what we're going to do, we're going to look at the first bit, which is the oxidation. Now oxidation, the definition you probably know by now, is actually addition of oxygen or loss of electron. In this case we will look at the gain of oxygen. Sorry, I think I said loss of oxygen. It's actually gain of oxygen or loss of electrons, and that is called oxidation. Now here you will have the alcohol which has the hydrogen and 1 oxygen, but there's one more definition which is actually a loss of hydrogen. Gain of hydrogen is called reduction. When you lose a hydrogen, that will be called as the reduction. So alcohol, when you do oxidation, there are 3 types of alcohols, and you need to learn that as well. For example, if you have this alcohol, which is actually a propane, it's a propane, and if you put OH there, it is actually propane 1-ol. And if I put the hydroxyl group at number 2 position, it will be propane 2-ol. And if I put the OH there, and the reason why I did that, it is still going to be a 2-ol, 2-methyl propane 2-ol. The whole thing I have done it just for you to understand it. When the carbon which is attached with the OH directly and is connected with one carbon atom directly, that is known as primary alcohol. Means 1-not alcohol. When the OH group, which is attached with the carbon atom, and that carbon atom is attached with 2 carbon atoms on each side, that will be known as secondary alcohol. So you can say is 2-not alcohol. When the carbon which is attached with the hydroxyl group is attached with 3 carbon atoms directly, it will be known as a tertiary alcohol. This one cannot be called a secondary alcohol. A lot of people get mixed up with this. You cannot call it a secondary alcohol. Even though you have 2 carbon atoms, only one of them is directly attached with the carbon of hydroxyl group. So you cannot actually use that as a secondary alcohol. So it is a primary alcohol. Now, before we actually get into that, let me clear the point here. The smaller alcohols like CH3OH, C2H5OH, these are actually more soluble in water. They are soluble in water, but as the carbon chain increases, the solubility decreases. melting point and boiling point also increases as the carbon chain increases as well. And the reason behind it, the smaller ones will create hydrogen bonding, and how they create it, that's what I'm going to show you. CH3 will have OH, so there will be partial positive and partial negative charges because of the difference of the atoms you have in the covalent bond. This hydrogen will be attracted by the oxygen of the other alcohol, so which already carry positive charge. So because a small molecule, the hydrogen bonding is going to be actually quite high, because this molecule can be circled by other methanol, and then it will be more soluble in water. The larger the carbon chain is, then it will be very difficult for one OH group to actually surround it. So what's going to happen here is it will be more soluble if it's a small alcohol. And you probably have noticed that when you put the alcohol in the water, the small one, which is actually ethanol, it does not show you two layers, it's just mixed up. Okay, if you do a large one, for example, you use a octanol, it might show you two different layers, like it will have an oily layer and the water underneath. So what we're going to do now is we're going to do the oxidation. So 3 different alcohols, primary, secondary and tertiary, all 3 of them actually react in a different way. So this one will react a different way, and this one, but the reagents will be same. For example, number 1, reagents for this chemical reaction in organic chemistry, we use K2Cr2O7, or you can use Na2Cr2O7. You can watch my other video, previous video, where I have actually showed you physically in the lab how you're going to do that. So that's the one of them. You can use them along with sulfuric acid. Now, analytical techniques are different. So there are distillation and reflux, 2 techniques we're going to use here. For example, if you decided that you have CH3, and I'm going to open these molecules for your understanding. This is primary alcohol. When you are going to do oxidation, you are not going to do O, you write down here O2. It is actually O means one atom. O2 means it's a combustion. So that's why you have to write down one oxygen. On the arrow, you will write down K2Cr2O7 and sulfuric acid. If you use here distillation, methanol will be converted into ethanol will be converted into ethanol, Al. This is ethanol. This is an aldehyde, this is an alcohol. Now, a lot of people actually try to remember it by heart, and they always struggle with that. Let me actually give you a shortcut to remember. What's going to happen is oxidation is actually a loss of hydrogen. So in oxidation, every time you do oxidation, you need actually 2 hydrogens have to be removed for one oxidation. All right. So one hydrogen will be removed from the OH, and other hydrogen will be removed from the carbon atom, which is directly attached with OH. So here you have OH, and here you have another H. So 2 hydrogens will be removed, and then the oxidation will happen. If I remove those 2 hydrogens and I try to explain it, you only left with 1 hydrogen, so I will write that hydrogen as it is, and then you will have 1 oxygen left there. I put that oxygen as it is, and then oxygen belongs to group 6, so it has to have like 2 bonds. Carbon belongs to 4 groups, so it has to have 4 bonds, so now it is a stable molecule. But when you look at this, it's a pretty straightforward. Ethanol is produced when you have distillation. But what if I change it and I use reflux? With the same reagents, K2Cr2O7 and sulfuric acid, what's going to happen here is this one will go further. It will produce aldehyde first, and then you do reflux with K2Cr2O7 and everything. It will further oxidize. Another definition is gain of oxygen. So what's going to happen there now? This hydrogen here, you will actually add 1 oxygen. So this will be converted into CH3, C double bond O, bond OH. So that is a carboxylic acid. It is ethanoic acid. Now, you have done the primary alcohol oxidation. What I'm going to do is I'm going to change it, and what I want is I would like to see what's going to happen when you actually have a secondary alcohol. So if I use CH3, CHOH bond CH3. This is propane 2-ol. I'm going to do oxidation with K2Cr2O7. It doesn't matter distillation or reflux. What's going to happen here? You remove 2 hydrogens. One from the OH, the law is same. One from the same carbon atom, but from only 1 hydrogen atom. When you remove everything, I'm just going to write down the molecule as it is. CH3, CH3. I only left with 1 oxygen, so that will be the... Now this is called propanol. This is propanol. A ketone is produced. So it doesn't matter whether you do reflux or distillation, it will produce. Because you cannot do further oxidation of ketone. Why? Let me explain that. When you have produced aldehyde there, you have 1 hydrogen. So you have to have, for the further oxidation, you should have 1 extra hydrogen so the oxygen can be added. Because you do not have that hydrogen there, then that's why it's not going to be added there in any way, because carbon to carbon or carbon to oxygen bond is very strong. So you can't break any of these bonds to add more oxygen. So it will not go under further oxidation. Now this part, distillation, is called partial oxidation. So if you see this word partial oxidation, which means only distillation. When it says full oxidation or just oxidation, you will carry on. And I recommend you, please do not try to remember these by heart. Try to understand it, that you remove 2 hydrogen in the first step and then you add oxygen in the second step. Because there is no hydrogen available onto this carbon atom, that's why it cannot further oxidize. Carbon to hydrogen there is not going to actually entertain any of the addition of oxygen atom. Now the third part is obviously we have the tertiary alcohol, and tertiary alcohol obviously is one of those which I have wrote on the right hand side. You can see that 2-methyl propane 2-ol. The moment I'm going to do oxidation with the K2Cr2O7 and then we have a H2SO4, you can do reflux or distillation, whatever you're going to do, reaction is not going to happen. Why? You can see that I gave you a rule that you have to remove 1 hydrogen from there and 1 hydrogen from this carbon atom. You cannot remove the hydrogen from the other carbon atom. So there is no hydrogen. So the tertiary alcohols cannot be oxidized. You cannot oxidize. Oxidation will never happen in the tertiary alcohol. Now, what I'm going to do is, if you want to make notes, I'm just going to move away. You can take a screenshot. And next part is we're going to look at the elimination direction. Now, you have been doing that chapter of alkenes, where what you did is you have done the hydrolysis, which means the reaction with water under sulfuric acid and all these conditions. You have made hydrogen will be added on the 1 carbon atom and OH will be added to the other carbon atom. Okay, that's what you did in alkenes. This is called hydration. So when you have moved this way, this is hydration. When, like in your classroom, you say, can I hydrate myself because I need water? Now, when you are not feeling well, you have to reverse this process, which is called dehydration. Now, dehydration looks very simple. You have to understand you cannot remove OH and H from 1 carbon atom. Like you have done here, you added these two to 2 different carbon atoms. So, what you're going to do there here, for example, if I have butane 2-ol, okay, I'm going to do dehydration, which will happen in under H3PO4, or in the classroom it will happen under H2SO4. One of them can do the job for you, but this is industrial scale, we use that. When you do dehydration, you have 2 hydrogens on the neighboring carbon atoms. So one of them can go, so which means you will make 2 products. In one product, if let's just say if you remove this hydrogen and then this OH, the double bond will appear between these 2. So that will be the but2ene. Here you have this hydrogen as well. So if you make that, you will be making a double bond there, which means you will have but1ene. Now the problem we have here is, when they looked at the reaction mixture, they said basically they have not two isomers. These two are position isomers, but they saw three isomers. They said there are three isomers present. These two are the structural isomers because of the position of the double bond is changing, like you have done in alkanes. But the other two isomers, which one of them? So one of them is showing dual isomerism, what means the structural isomerism, at the same time it is showing you stereoisomerism. When you look at this but2ene, you remember that in one of the subject in alkenes, if you have learned it, when you have the alkene, the carbon-to-carbon double bond, and it has got two different groups on each carbon atom, they can show you Ez or cis-trans isomer. So this but2ene will show you cis or trans or Z or E isomerism. Alright, that's why you have 1, 2, and 3 different isomers. Now, this process or this whole thing, which is called dehydration, but it has another name. The name of the reaction mechanism, that's very important. Reaction mechanism name. Because you have removed these two, you haven't added anything, you haven't done anything else, so it will be actually elimination. So you cannot say nucleophilic elimination or electrophilic elimination because you have removed H positive ion and OH negative ion from there. So you can, and in the first, so you can't say that which one is going to move. So it's a elimination reaction. One more chemical reaction which you've been doing, especially in a haloalkane. If you have an alcohol, for example, CH3, CH2OH, and you're going to react with hydrochloric acid, and you produce CH3, CH2Cl plus H2O. Though this hydrochloric acid is better if you actually react to the sodium chloride with sulfuric acid and produce the chloride, hydrochloric acid and sodium sulfate, and then the chloride ion will be more available. But that's something I'm not going to get into. What I'm trying to say here, the hydrochloric acid will give you chloride ion. Chloride ion is a negative charge particle. OH is also a negative charge particle. So what's going to happen, both of them, they will exchange the place. Anything negative or anything which has got a lone pair of electron on it, in chemistry we call them nucleophiles. So the nucleophiles actually swap the place. So it is called nucleophilic substitution. All right. So that's the whole thing about alcohols for A-level chemistry. Thank you very much.